So it's, I guess, probably not by accident that most everyone on this panel is coming from the building and architectural scale of design and fabrication, which is interesting because, you know, when you're trained as an architect or civil engineer, structural engineer, usually you're borrowing innovation from other industries. Automotive and aerospace we've always looked to since modernism as being inspiration for technology. But do you think that there's opportunity now for the other industries who are now trying to build more customized products to learn from architecture and buildings? And I'll open that up to the panel.
I think that's exactly what's wrong with the current approach to product design, is that it has grown out of this, how can we make the most things cheaply, where architecture, you get taught, how do you make something most appropriate for the use case or the user? And I think that what we now need is for product design and other fields to start pulling from architecture, just as you said.
I mean, one result, like it's quite clear in the last 5 years, is that there are a whole series of graduating students from architecture programs who have all these skills that don't really apply to a regular architecture practice, you know, programming, robotics, etc., a whole series of things that are getting into Bill Kreis's workshop, getting into all sorts of places. So architecture in that regard is already contributing outside the field greatly. I mean, we've seen a number of architects present today. I mean, Francis Vitoni this morning.
Another recovering architect, right?
Exactly.
Well, we're the only ones who get taught generative design. They don't teach it in any other field. So how you create algorithms that can then create forms automatically is something that's sort of unique to our space.
You know, one thing I've discovered that the entire vernacular of traditional mechanical engineering has been built out of existing manufacturing processes. Just the terms you use, features, bosses, pockets, fillets, chamfers, are all derived from manufacturing process that we're all potentially going to render irrelevant. And so it's almost like an entirely new language has to be developed around this.
I think in many ways the skills that an architect possesses are necessary to this emergent field of scanning and computing and creating. I mean, it's a very spatial field, and it's really architects in a few other fields that learn the tools of understanding space, of 3 dimensions and 4 dimensions. And so I think it's going to be requisite that the industry learns from what architects perhaps already know.
And the other side of it is we've been playing around with printers since like the late 90s.
This is before they're cool, right?
Before they were cool, because it was cheaper for us to use a printer to make a model than to have our entire firm sit there working on a model all weekend. And so that was the only place where there was an economic benefit to printing for a long time until it got as cheap and accessible as it is today.
Yeah, no, and I'd agree. And from another aspect, I think that by the nature of making bespoke buildings that have to be designed to a really high level of refinement, we're becoming really, really well versed in some really, really lean construction and design practices. Stuff that my firm has been working on, from like big projects like Water Cube. And that building was designed in an incredibly short number of months. And it's just all going down to really automated processes that have very, very like highly technical automated workflows. A lot of it in-house customized solutions. But yeah, I think we're learning some very, very powerful, good bespoke tools just by necessity.
It's kind of transitioning from explicit design where we actually draw the thing to creating the systems that draw the thing for us, right?
Exactly.
So we have maybe time for one question from the audience. You guys have any burners for these guys? Really? Out of all that, you don't have any questions? Here we go.
Going back to this issue of computational intensity, I'm just, speaking as a layman, I'm just wondering, like, what's your take on high performance computing? What do you use? How many of your projects are running in the cloud?
I will handle that first, being a representative from Autodesk, is that obviously we view the cloud as being the only way for this to happen. I think some of the challenges you see now is that a lot of these tools are so new or home built that haven't been architected yet to leverage cloud computing. So you still see a lot of optimization being run on local clusters, but that's starting to change now. You're seeing a lot more cloud-enabled optimization starting to happen. But you guys have any particular pain points or successes to explain?
That's what you're doing with the Spark platform, right? Is actually creating those cloud-based GPU tools so that we can do much more heavy, much more computationally intensive work than what our local machines have allowed us to be capable of.
I mean, it's already happened in rendering, for example. So, you know, I don't think anyone runs serious ray tracing on local machines anymore. That's pretty much all cloud driven. But I mean, you guys went through some of the pains of optimization on, you know,
Sure.
unparallelized local systems, right?
Well, that's also, you know, there's a structural engineering professor who's been doing it for 20 years who's, you know, got his embedded systems. And I mean, my only thought on that is that, you know, optimization algorithms are only relevant to the criteria you set for them. So if we're just, you know, we've got to start to set better criteria, understand, sort of design these algorithms in different ways, potentially. Certainly the ways, you know, big picture criteria for what we're all doing on some level is cost. How do we start to build that into the optimization algorithms we run, or certain types of efficiencies?
Which is interesting because now the designer has to be thinking about this at the outset, right?
Yeah, somehow sort of trying to be, you know, this is the architect's trying to be across everything, yeah, or as much as possible.
But that just becomes another object for the algorithm to optimize for. You know, if you design it right, it should happen automatically.
You have to know which questions to ask up front.
Yeah, and as far as going back to the question just about cloud-based solutions and parallel programming and stuff, like, yes, we're finding that that's an absolute necessity, and a lot of the problems that we're trying to solve are very embarrassingly parallel. So yeah, our software group has been really investigating that, and we've pushed that as a solution on a lot of our recent projects. So yeah, there's a huge place for that going forward.
Cool. Well, thank you all. This was excellent. I learned a ton and was very entertained. Thank you, guys. Please give them a round of applause.